Alright, we are back with HED 241 Biostatistics and Public Health. We are moving on to, we're still in Part B, Descriptive Statistics. We are looking at Section 8, the mean and average. I think a lot of you all, and I don't really want to make this full assumption, but that a lot of you all have learned about means or averages in potentially college algebra. If you've taken another statistics course, you definitely have. It's probably going to be a review for most of you, and I hope so, and I hope this is one of the easier sections in the book. If it's something that's new to you, something that is not one of the easier sections in the book, don't panic, but please make sure if you have questions that you let me know so we can get them clarified, because I definitely need you to understand Section 8 as you move forward in the textbook. That being said, mean. So your mean is the most frequently used average. Okay, so widely used, most people just refer to the mean as the average. Okay, those two terms are very interchangeable. You'll probably hear me even on this use them interchangeably. They're used pretty interchangeably in your textbook. Go with them being the same. The symbols for mean, you do need to know these for sure. X with a bar over it, this is usually the mathematical statistic. M, the capital M that's italicized, and then the lowercase m that's italicized is used in academic journals. Know that the uppercase is used for the mean of a population and the lower case is used for a mean of a sample drawn from the population. Make sure you know the differences. The mean is a balance point in your distribution of scores. So if you think about a seesaw, your mean is going to be what's right in the middle that kind of keeps them balanced. Okay, it's not the middle point, but it's where the middle weight is. Okay, specifically it's the point around which all deviations sum to 0. The mean is sensitive to extreme scores. Make sure you know that, so we're going to talk a little bit more about that in a minute. Computing the mean. So computing the mean is really pretty easy. I think you probably honestly learned it somewhere 4th, 5th, 6th grade. But we also know it's been a while, so how's it done? It means the average. So you sum, which means you add all the scores, and you divide them by the number of scores. Here's an example. You have scores of 5, 6, 7, 10, 12, 15. Sum of the scores is 55. You can check my math, but if you add all those up, you get 55. There are 6 numbers, so there are 6 scores. You take the sum, 55, divide it by the number, which is 6. You get 9.166, which equals 9.17. Notice that all answers are rounded to 2 decimal places. That's what I want you to do for everything you do in the course. We're going to always round to 2 decimal places. So anytime you're doing math, make sure you round to 2 decimal places. Okay, so deviation from the mean. What do we mean when we say deviation? So we're talking about the amount by which a single measurement or score differs from the mean. So think about it as like the distance from the mean. That might be the easiest way to remember. Deviation, distance from the mean. Okay, so subtract the mean from each score to find the deviation from the mean. So remember, the mean is the balance point in a distribution of scores. Specifically, it's the point around which all deviations sum to 0. So let's look at this again. Okay. Score example, you have 7, 11, 11, 14, 17. The sum of that is 60. The number of scores is 5. So the mean is 60 divided by 5, which is 12. So you now know your mean is 12. Okay. So to compute the deviations from the mean, these are your same scores. I promise if you go back one slide, it's these scores right here. Okay. The mean is 12. We determine that right here. Okay. The deviation, what you do is you take 7 and you do it in this order. You take this, 7 minus 12, it gives you a negative 5. 11 minus 12, negative 1. 11 minus 12, negative 1. 14 minus 12 is plus 2. 17 minus 12 is plus 5. You add all those up, you get 0. Okay? So here, so substitute for another number for the mean. So let's say we pick another number. We say the mean isn't 12, we think the mean is 10. Do you see how the sum of the deviations changes? So you know that that is not correct because the sum of deviations should be 0. It's a way to always check and make sure you have your mean score correct. If when you do the sum of deviations, it does not equal 0, you do not have the correct mean. Or your math somewhere in here was wrong. Okay, so that's always a way to tell. Alright, so major drawback of the mean. The mean is pulled in the direction of extreme scores. So if you have extremely high scores, it will pull the mean higher. If you have extremely low scores, it will pull the mean lower. What do I mean by that? Let's look at this. Group A, we have just numbers 1 through 11, thrown in here. The mean is 5.52. Okay, so your lowest is 1, your highest is 11. Group B, 1, 2s, 3s, 4s, 5s, 6s, 9, 10, 10s. Then you add 150 and 200. Look what happens to your mean. It goes to 21.24. Okay? Do you see the difference here? So all we added were 2 numbers, but it really pulls it to the extreme. So when you have those large numbers, it pulls it to the extreme. So extreme scores, a distribution that has some extreme scores at one end, but not the other end, is called a skewed distribution. Limitations of the mean. Mean is almost always inappropriate for describing the average of a highly skewed distribution. So like our example, when you added the 150 and the 200, mean is not really the best way to describe that, to pull the average, because those are really what you call outliers. Okay? The mean is only appropriate for interval or ratio scales of measurement. Remember that. Remember that from the last part A of the textbook, when we talked about levels of measurement, scales of measurement, interval and ratio, because it's equal spaces between. So that's the only time you can use a mean. Another term you might hear for average is also measure of central tendency. It means the same thing. Okay. So section 8 questions. Make sure you know all of these answers. And be sure to pay attention to your specific assignment within Canvas to know which assignment you need to complete this week, which specific sections, and all of that good information. As always, if you have any questions, please let me know, and I'll be happy to answer them.